So today we're doing another question here called square and sum. So we want to essentially complete the square sum function so that it squares each number passed into it and then sums the results together. So for example, for this particular array here, we have 1, 2, and 2, and it should return 9. And the reasoning behind that is it squares each number. So the square of 1 is 1, the square of 2 is 4, and same for the one that follows. And then it does 4 plus 4, and then plus 1, of course. Then it returns 9. And so we square each number, and then we add it to the sum, right? Which would essentially store the addition of those squares. Now, the first thing that I assume is that it can be done with one for loop. One for loop can essentially square the numbers, store them in an array maybe, and then another for loop can actually take that array and add all the numbers together. But always ask yourself, when you're using two for loops, can you instead just use one? So here I'm going to have an integer which is called the sum equals 0, and I'm going to iterate for the length of the array. I is less than n dot length, and I'll increment I by 1. And in here, essentially what I'll do is I'll have an accumulator pattern. I'll say sum is essentially equal to sum plus n of I, right, times 2. And then I'll return the sum. So it seems like we failed the first test, and sort of the reasoning behind that is that we're actually not squaring the number. We're actually just multiplying it by 2. So instead of squaring the number, we could actually just multiply it by itself. In fact, that's what squaring a number really means, and you multiply it by itself. And so that's really the reasoning behind why we failed the first test. So just some really simple code there. What could be a possible other way of going about it, right? What could be maybe an inefficient solution? So an efficient solution looks something like this, and perhaps an inefficient solution could look well, in terms of efficiency, I'm sure I could omit this completely and just use the shorthand operator, right? And that essentially would still work. I mean, it would give me more or less the same answer. And in regards to efficiency, I mean, so I think we could just do something like this. Maybe if we were really inclined to sort of get the code down in as many lines as possible. In fact, I think you can just return. You can actually have it in just one line, but that looks pretty weird. It's not. I don't think it's readable in that sense. But if this was, if I was trying to explore what an inefficient solution would look like, I would first I would have sum, equate that to 0, use a for loop, and I is equal to 0, I is less than, let's say, n dot length, right? Because the array in question is in fact n. Increment I by 1, and what we'll do here is we'll actually have another integer which will hold the square of any particular number referenced by the index. So square will equal a new value each and every time the for loop iterates. So the square will equal, well, it can equal, let's say, math dot pow, right, which would essentially take n of I and then square that, we'll just to the power 2, right? And since this only takes doubles, since math.pow only takes doubles, we have to cast it to an int. And then I'll have an accumulator function which will essentially add that square onto itself and then return the sum, not the square. And that works as well. But of course, we could have just done sum is equal to plus equal to square. That would also work, right? What else could we do? Yeah, so essentially my other alternative was to have another array called new array equal to, well, yeah, so I think I'd have a new array, and then that would equal to new int, and then the length of the original array, which is n. And essentially what we would do is we would go through n, and we would square, let's see, what we'll do is we'll have new array at index, well, I think we can work in sort of sync with the original array. New array of I will store n of I. Well, it's going to store, so I think we'll have int index equals to 0, and it will store n of I times n of I, right? Right, so yeah, I think we could just do this without the index. And after that, well, so this is populating new array. So the first iteration, if we had, let's say 1, so new array at 0 at the first element would equal 1 times 1, which is just 1. And then the second iteration, where I would be equal to 1, we're on the second element. The second element would be n of 1 times n of 1, which would be 4. So I think this would work. And then after this, we would essentially add all elements in new array. So we'll have int sum is equal to 0. We actually already have some at the top, so I guess I'll take that away from there. And we'll have a for loop, and I is equal to 0, I is less than new array dot length. I mean, they're the same length, so it doesn't really matter. Increment I by 1. And sum will equal to sum plus new array of I, shorthand. Return sum. Maybe this will work, not too sure. Yeah, int cannot be converted to an int. Let's see what's going on here. N dot length. You know, I'm not too sure. I'm probably overcomplicating this way more than it needs to be, but